Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. Now I'm welcoming you all to this beautiful online learning platform. Now we are happy to announce that Unacademy is going to providing online classes for the students who are appearing for their GATE and engineering service examinations. For the students who are appearing for GATE and engineering service examinations, for them Unacademy is providing online training. About myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. First we check how to get Unacademy learning app into your device. Just go to Play Store, type Unacademy, By typing Unacademy, it will show the Unacademy learning app like this. In this, here there is an install button. Just click this install button. By clicking this install button, it will install the Unacademy learning app into your device. Once you open that, it will shows what are the different courses available in that and each course handled by which faculty. It will shows that information. And at the same time, here are the few of the top educators who are working under Unacademy. If you check, see this Tiwari sir, he is the IIT topper. He has 7 years of teaching experience in GATE and he is the author of a book, GATE in 75 days. GATE in 75 days. Next, Ankit Goyal sir, he obtained 2 times All India first rank in GATE Electrical and he was awarded President of India Gold Medal in IIT Indore. And Sanchit Jain sir, he has a sound experience in teaching the students. He has more than 8 years of experience. And Jaspal Singh sir, he is ex-IAS officer. He got All India 4th rank and he is the ex-senior Made Easy faculty. So for service examination, state service examinations and GATE, he is the topper. Okay, these are his credentials. Now, from this, because of this, we are saying that we are claiming that our educators are the top educators. Now, here are few more top educators from Unacademy. Now, there is a test series going on in Unacademy for engineering service examinations 2021. This test series was curated by the best educators and All India live rank is provided if you are attempting the test by online, and it was designed as per the changing demand for engineering service exams. In this, there are 10 questions, 20 minutes of duration for that. These are the different departments and the respective dates on which dates this test is going to conduct. So for mechanical, it is on 22nd and 29th March. For electrical, 23rd and 30th. For civil, 24th and 31st. For electronics and communication, it is 25th March, and for general studies, it is on 26th March. Okay, these are the dates. Every month it is conducting 2 times. But for electronics and communication, it is on 25th March. Please take a note down these dates. And general studies, it is common to all. It will conducted on 26th of March. Okay, now don't forget To unlock this, use my code VRAO10 to unlock this test series. Okay, now I am wishing you all the best to all the participants, all the students who are going to attempting the test. Next, there is a full length mock test. Full length mock test. Full length, that means there are 150 questions and 180 minutes of time for different departments. Here is mechanical engineering, electrical engineering, civil engineering, electronics and communication engineering. And it was on 21st and 28th of March. Time is 10 a.m. at 10 o'clock. Okay, and the same way to unlock this series, use my code VRAO10. Next one is so there is a golden opportunity for civil engineering students. So crack engineering service exam with Jaspal Singh sir. Join us for free test series. These are the topics, different topics, and the respective date. On that day, there is a test series on that topic. The Jaspal Singh sir. Okay, he is the one of the topper in IAS. He got All India 4th rank. Now there is a ultimate 10 SSC series for mechanical engineering students. There are 10 questions and 20 minutes of time. Now it was conducted at 10 a.m. on these days, March 1st, 4th, 9th, 12th and 17th of March. Okay, it was curated by the best educators and All India live ranking is provided. And it is a design for changing demand for SSC, and the test you can attempt after the test live session also. After live session of completed, also you can attempt the test. Okay, now don't forget to use my code VRAO10 to unlock the test series. Now we are moving to electrical engineering. For electrical engineering, there is a same exam but at different dates: 2nd, 5th, 10th, 15th and 18th. There are 10 questions and 20 minutes of time. The timing is at 10 a.m. Okay, it was curated by best educators. All India live ranking is provided and designed as per the changing demand for SSC. Okay, and you can attempt the test after completion of online session also. And don't forget to use my code VRAO10 to unlock the series. Next, I am going to civil engineering department. For civil engineering department, there are 10 questions, 20 minutes of time. Now the same time, 10 o'clock, dates are different: 3rd March, 8th March, 11th March, 16th March and 19th March. Please take a note down the dates properly. Next, GATE. So kickstart your GATE 2022 preparation. Now there are 10 questions, 20 minutes of time. Now every Tuesday, Thursday and Saturday tests are going to be conducted. Now this test is at 10 o'clock and these are the different departments: mechanical engineering, electrical, computer science and IT department, civil engineering, electronics and communication engineering and chemical engineering. Now we are happy to announce that recently we started 2 new batches, one for GATE 2023 and another one is for GATE 2022. There is a Ascend batch for GATE 2023 for mechanical engineering students. So this batch was started from 22nd February 2021. Here are the top faculty who are working under this batch. And next there is a same team is going to handling the subjects for GATE 2022 also. Same faculty are handling the GATE 2022 for mechanical engineering students itself. It was also started from 22nd February. And one more important thing is there is a mission DDR we started for mechanical engineering students. Mission DDR. This is for GATE 2022. This batch was started from 22nd February 2021. And don't forget to use my code VERA10 during subscription. By using my code VERA10 during subscription, you get it by 10% discount. So here are the top faculty who are working under this: Tiwari sir, Uma Maheshwar Rao sir, Meenu Gupta ma'am, and Aman Rao. Here are the top faculty who are working under this. Now there is a Spark batch going on for civil engineering students for GATE 2022. This is only English batch. Here are the top faculty: Krishna Prakash sir, Rajendra Prasad sir, Rajendra Prasad sir, Praveen Kulkarni sir. Here are the top faculty who are handling the subjects in this batch, and this batch was started from 22nd February 2021. Next, there is a Ascend batch for GATE 2023 Civil Engineering. This was started from 8th February 2021. Here are the top faculty who are handling the subjects in this batch. The same faculty are handling the subjects for GATE 2022 also for civil engineering. It was also started from 8th February 2021. Next, there is a Evolve batch for GATE 2022 for computer science and information students, technology students. Now, it was started from 8th February 2021. Here are the top faculty who are working under this: Ravindra Babu sir, Sanchit Jain sir, Subbarao sir, Mallesham sir, Vishwadeep sir, Shweta Kumari ma'am. Here are the top faculty who are working under this. Next, we move to electrical and electronics department. Now in electrical engineering, there is a Ascend batch for GATE 2023. This batch was started from 1st February 2021. Here are the top faculty who are handling the subjects in this. Next, there is a Ascend batch for GATE 2023 for electronics and communication engineering students. This batch was started from 1st February 2021. The same faculty. So the same faculty are going to handling the subjects for GATE 2022 also. Now there is a Evolve batch for GATE 2022 for electrical engineering students. Same faculty who are handling the GATE 2023 for electrical, the same faculty are going to handling the subjects in this one also. And this batch was started from 1st February 2020. Okay. Now, so there is a Evolve batch for GATE 2022 for electronics and communication engineering students. This batch was started from 1st February 2021. Here are the top faculty who are working under this. Don't forget to use my code VERA10 during subscription to get 10% discount. Last but not least, chemical engineering department. There is a Evolve batch for GATE 2022 for chemical engineering. This batch was started from 25th January 2021. Here are the top faculty or top educators who are working under this. Now just we glance what are the different engineering disciplines available in Unacademy for GATE and engineering service examinations. There is a electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, production and industrial, civil engineering, last but not least, electrical engineering. These are the different engineering disciplines available in Unacademy for GATE and engineering service examinations. Next, there are two subscriptions basically. One is plus subscription, other one is iconic subscription. Plus subscription is the basic plan. Plus subscription is the basic plan. And iconic subscription take your preparation to the next level. Here we are providing a personal coach to you. With the help of this personal coach, you can enhance your preparation. Now, in both the case, your India's best educators are handling your subjects, and there are interactive live classes are there, structured courses and PDFs, live tests and quizzes are there. Here, once you've written the test is going to be analyzed by personal coach. Whoever the personal coach we are assigning, that personal coach is going to analyze the test. Okay, so there is a personal coach we are providing. That personal coach is going to analyze your test. So based on the analysis of your test, proper study planner we will provide, and respect to study material also provide to you. Every student, by following these three, they can get success in their examinations. Okay, so here we are providing personal coach to you. Don't forget that we are providing personal coach to each and every individual student. Next, there is a plus plan. Plus plan is available at different subscriptions. There is a 1 month subscription, 3-month subscription, 6-month subscription, 12-month subscription, 1.5 year subscription, and 2-year subscription. Okay, and the beauty here is EMI option also available for every subscription. EMI option also available. Now, as a faculty, I recommend the students to take minimum of 1 year subscription, because this 1 year is required for a student to prepare all these subjects effectively and to rewind the subjects multiple times. That means to repeat the subject multiple times, and after that to write number of examinations, to identify the gaps in their preparation. That means by analyzing his exam paper. Okay, so for doing all these things, for a student required minimum of 1 year time. Okay, so my dear students, and one more important thing is the cost of this one is 30,250 rupees. Okay, by using my code VRAO10 during subscription, you get it by 27,225 rupees only. 27,225 rupees only. And this amount is more or less close to the amount you need to spend for a transport if you join somewhere outside for taking an offline training. For transportation, whatever the amount you need to spend, this is the amount more or less close to that. Okay, so my dear students, please think once of it, and by spending your transportation amount itself, you can complete your GATE preparation, GATE training from India's best educators. Okay, so now we are moving to the next one. There is an iconic plan. 12, it is available in two subscriptions, 12-month subscription and 24-month subscription. For 12-month subscription, it is 50,250 rupees. By using my code, you get it by 10,000 discount, 10% discount. After discount, it became 45,225, and we are charging this amount for personal coach. We are providing a personal coach to each and every individual student. Okay, the purpose of the providing personal coach is to analyze the exam paper, what he written. Okay, what you written, and after analysis, we need to provide a proper study planner to you. Okay, time to time that has to be updated, and your progress has to be known time to time. For doing all these things, we are providing a personal coach. For that purpose, we are using personal coach. Because of that, we are charging that amount. So don't forget to use my code VRAO10 during subscription. Okay, now please discuss with your friends, your family members, and your faculty who are having knowledge on GATE and engineering service examinations. Okay, take a rendition. Thank you. Thanks for spending your time. Now we are moving to our today's topic. Just a minute. Already last session we completed some portion. Now I'm going directly to that part. So types of, this is the construction and this is the three-dimensional representation. So we calculated the channel resistance and depletion region width here is there. In this diagram we mentioned depletion region width is W0. Here I am going to calculating the depletion region width. That is see, we know the depletion region width at a junction is W0 is square root of 2 epsilon by q 1 by NA plus 1 by ND into V0. But here gate doping is much greater compared to channel doping. Gate is a P plus material and a channel is a N type material. So once it is P plus Na, it is N type, it is Nd. So Na is much greater than Nd. Therefore 1 by Na is much less than 1 by Nd. So we can take 1 by Na plus 1 by Nd is approximately 1 by Nd. Therefore depletion region with the W0 is square root of 2 epsilon by q Nd. This 1 by Nd can be 1 by Na plus 1 by Nd is written as 1 by Nd into V0. Sorry. Your V0 is not here. Here is your V0. That is your V0. Okay. This is the depletion region width. Now, by changing the gate voltage, the depletion region width between gate and channel varies, and it extended more towards lightly doped channel region. That means, therefore, channel resistance is changing and conductance also changes. It is what it means. This is the FET we are taking. Here is the P plus diffusion, heavily doped, Actually we are expecting, this is the actual channel what we have, actual channel what we have. But this is lightly doped n-type semiconductor, it is heavily doped, some depletion region is there, some depletion region. Okay, so due to this depletion region, now this is going to be your net channel. Fine. See, now we treat this is the maximum available channel. This is the maximum available channel. Because this depletion region should be there always. So now here what happens is, this is the gate terminal and this gate also shorted to this. Now we are going to applying a voltage at a gate terminal with respect to source such that the gate current is 0. Gate current 0 means, and one more sir, this is your drain terminal. Here is VGS. I am applying VGS negative. Negative. When VGS is negative, then only the gate current entering into this one is 0. Only a leakage current flowing through the junction. Only a leakage current is flowing through that. So compared to remaining things, that leakage current is negligible. Now, here what happens is, here, once VGS is negative, let us, I am keeping VDS constant. Some VDS we are applying. We keep varying VGS. VGS increasing in the sense the reverse voltage between gate to channel is going to be increasing. Once reverse voltage is varying or increasing, the depletion region width is going to be increasing. And that too, it is extended more towards lightly doped channel region. Now, for example, I increased this. After increasing that, your channel is, depletion width is increased. Let us, this is the depletion region. This is the depletion region. It is extended. Here also depletion region is like this. Okay. So once the depletion region is like this, now the amount available channel, the amount of channel what is available here is going to be, channel what is available is going to be decreasing. Early days, initially this much channel is available to us. Initially this much channel is available. Now the available channel is only this much. Channel is decreasing. Available channel is decreasing. Once channel is decreasing, the amount of current also going to decrease. Okay, that is what we are going to be doing by applying VGS. Yeah, the change in conductance by changing in gate voltage. By changing gate voltage is known as conductance modulation. Yeah, see this. Channel is varying, channel is decreasing. That means the resistance offered by the channel is increasing. Okay, so that means conductance also, resistance varies in the sense conductance also is going to vary. Okay, so once conductance also going to vary, that is called conductance modulation. Conductance modulation. Okay. Next. Now I am going to operating this FET. Okay. See this. Now I am going to operating this. I am keeping VDS constant. VDS constant. and varying the VGS, keeping VDS constant and varying VGS. Now in step 1, see this, we are keeping VDS constant and varying VGS. In step 1 I am taking VGS 0. So once VGS is 0, I am taking, and after that I am applying constant VDS to this. Now once in VDS we applied, it became positive and it became negative. It became positive and it became negative. So once it is positive and it is negative, electrons are attracted towards this side, drain side. Now current is flowing in opposite direction. Current is flowing in opposite direction. That is the drain current. If this much channel is available, more carriers flow per second, we get more current. If channel is decreasing, less carriers will flow, we get the less current. That depends on the amount of channel what is available there. It depends on that. Okay. Now, once VGS is 0, the channel available is, there is no change in the depletion region. Once VGS is 0, whatever the depletion region existing at the time of open circuit condition between gate and channel, whatever the amount of depletion region available, even with VGS 0 condition also same value is available. Same thing is available. Okay. So that means full channel, whatever the maximum possible channel, that maximum channel is available for conduction. Once maximum channel is available, you get the ID maximum. So now that maximum ID I am taking as IDSS. So at VGS equals to 0. So is maximum at VGS equals to 0. ID is maximum at VGS equals to 0. Therefore, IDSS is the maximum drain current. IDSS is the maximum drain current. Okay. Next. Now, this is one of the important slide. See this? So VGS is negative and VDS is positive for N channel JFET. Just before we operated N channel JFET, VDS is positive and VGS is negative. Okay, because we have to reduce the channel, we have to apply a VGS such that gate current should be 0. So VGS is negative. VGS is negative and VDS is positive for N channel JFET. VGS is positive and VDS is negative for P channel JFET. And one more thing, in previous gate examination they asked this question. In previous gate examination. Don't forget that. Now VGS is less than 0. Now I am going to apply. That means VGS is negative for N channel JFET. Once VGS is less than 0, gate to channel junction is in reverse bias. This gate to channel junction is reverse bias. Once this gate to channel junction is under reverse bias, what happens? Depletion region width will increase, and that too, it will extend more towards lightly doped channel region. And it will extend more towards lightly doped channel region. Okay, more lightly doped channel region. Now channel is going to decrease. Yeah, see this. When VGS less than 0, VGS is negative. Gate to channel junction is in reverse bias. So the depletion region width between gate to channel increases. Therefore, it extends more towards lightly doped channel region. So it means depletion region here. So extended more towards lightly doped channel region. Here you can observe it is extending more towards this. Okay, it is extending more towards this. So once, so the amount of channel is decreasing. So once channel is decreasing, channel resistance is increasing. That means RDS. So ID is nothing but a VDS by RDS. We can write drain current. This is the drain current. This is the drain current. ID. Once channel is decreasing, ID is going to decrease. So RDS is increasing. That means channel decreasing means channel resistance is increasing. Once channel resistance is increasing, ID is going to decrease. Therefore, there is a decrease in ID. Now, by considering all these things, I am going to see the same way I am going to increasing VGS in a negative direction. Once increasing the VGS in a negative direction continuously, what happens is channel available channel is going to decrease. Finally, it became zero. Channel is closed. Channel is pinch off. Closed in the sense channel is pinch off. Now the value of VGS at which your channel is closed is called pinch off voltage. And once channel is closed, the gate, there is no free movement of charge carriers. Then the current flowing through the channel is zero. Drain current is zero. So this is the case. Now once channel is closed, no more channel. Therefore ID is zero. Now the value of VGS at which your channel is pinch off is called pinch off voltage. Is called pinch off voltage. Now based on these things, I am going to defining the pinch off. Writing a plot. See, VGS channel is closed. The value of VGS at channel is closed. That means no channel is called VP, pinch off voltage. So VGS at ID 0 is called VP. Now these are the things so far we observed from JFET. At VGS equals to 0, ID is maximum. Therefore ID is maximum. Maximum ID we are taking as IDSS. And by increasing VGS value, that means in a negative direction, ID is decreasing. See, ID is decreasing. At VGS 0, ID is maximum, that is IDSS. And at VGS equals to VP, ID is 0. ID is 0. That is pinch off voltage. This is the plot for it. Now, the things what are available on the plot. I am going to relating these by an equation, that is ID is IDSS into 1 minus VGS by VP whole square. 1 minus VGS by VP whole square. Here VGS and VP both are negative values. Okay. And ID is a drain current. IDSS maximum drain current. VGS applied voltage between gate to source. And VP is pinch off voltage. In this plot, we are keeping VDS is constant. Don't forget that. And this is called transfer characteristics. Transfer characteristics. So next one is, I'm going to defining a new parameter, that is a transconductance GM, which is a dou ID by dou VGS at VDS constant, at a condition of VDS constant. So or dID by dVGS at VDS constant. That is the GM, transconductance. Now, so your value equation is ID is IDSS into 1 minus VGS by VP whole square. Fine. Now I am differentiating this with respect to VGS. So dID by dVDS, VGS equals to IDSS constant. Differentiating this with respect to VGS is this one. Now 2 IDSS by minus 1 by VP into 1 minus VGS by VP. This is the equation for transconductance. And after that, so here VP is pinch off voltage is negative. So negative into negative is became positive. Negative into negative is positive. So I am taking minus VP as mod VP. Therefore 2 IDSS by mod VP into 1 minus VGS by VP. Okay, now I want to get GM maximum. To get GM maximum, this is the definition for GM, dou ID by dou VGS. By taking this part 0, I get the GM maximum. So GM is maximum at VGS equals to 0. I am taking the same thing here. Now, see this. So GM at VGS 0 is maximum. That maximum GM I am taking as GM naught. Therefore, GM is 2 IDSS by mod VP into 1 minus VGS by VP. This is our equation. Just I am substituting VGS 0 in this. VGS 0. Now I get 2 IDSS by mod VP at 1 minus 0 by VP. This is the maximum GM. I am representing that one by GM naught. Now I am writing that GM naught is this much. Just in place of GM equation, in place of this I am substituting GM naught. So this is the another equation for GM. GM naught into 1 minus VGS by VP. Okay. Next one. See. So this is our equation for GM. Just before we derive 2 IDSS by mod VP into 1 minus VGS by VP, and we substituted in terms of GM. And 1 minus GVGS by VP I have. I am taking this one. This is our equation. From this I am representing 1 minus VGS by VP is square root of ID by IDSS. Square root of ID by IDSS. Substituting this one in this. By simplifying we get GM value this much. 2 by mod VP into root ID into IDSS. In terms of drain currents, we are defining transconductance. That's it. And pinch off voltage. Here, GM naught it is, and replacing this one by this one, root ID by IDSS. These are the different ways to represent it. Next one. So we are going to next one. Now this is our final GM. GM equals to GM naught into 1 minus VGS by VP. So here we are keeping VDS constant. Now I am plot this GM and VGS. At VGS equals to 0, GM is maximum, that is GM naught. By increasing the GM in a negative direction, GM value VGS in a negative direction, GM is going to decrease, and at VGS equals to VP, GM equals to 0. So this is the plot, transconductance plot. Okay, plot of transconductance in terms of applied input voltage. Okay, so next session we go on complete the remaining part. Thank you. Thanks for spending your valuable time with us, and don't forget to use my code VRAO10 during subscription. Please subscribe us, and please give your valuable comments on YouTube. Don't forget to hit the bell icon, and please join our Telegram group for getting latest updates on our upcoming videos. Don't forget it. Now, once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Thank you. Thank you very much.